Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of the Great Dying, Earth's worst mass extinction, and what really caused it. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. 252 million years ago, something killed 96% of every species living in the ocean. On land, 70% of vertebrate species vanished. Forests disappeared. Insects, which had survived every prior catastrophe, went extinct in measurable numbers for the only time in the history of life on Earth. What came before this event was a world of staggering biological complexity. What came after was nearly nothing. Scientists call it the Permian-Triassic extinction, or the Great Dying. It dwarfs the asteroid impact that killed the dinosaurs 66 million years ago. That event eliminated roughly 76% of species. The Great Dying nearly ended multicellular life altogether. Recovery took 10 million years, longer than the entire history of the genus Homo, and yet it was caused not by an asteroid, not by a gamma-ray burst from a dying star, but by volcanoes, specifically by the most sustained volcanic eruption in the last half-billion years, pouring lava across an area the size of Europe for 2 million years. How volcanic rock alone could nearly end all life on Earth is a question whose answer has profound implications for the planet we are changing today. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mecha, nicks of small bodies that deviate from the predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the mode as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies. The precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding the Great Dying, Earth's worst mass extinction, and what really caused it is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The Permian-Triassic extinction event occurred 251.9 million years ago and represents the most severe biotic crisis in the history of complex animal life. An estimated 96% of all marine species and 70% of terrestrial vertebrate species were eliminated, along with the only confirmed mass extinction of insects in the fossil record. The event is informally called the Great Dying. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the Siberian Traps, a vast volcanic province in what is now central Russia, erupted over a period of approximately 2 million years, straddling the Permian-Triassic boundary. The eruption produced an estimated 3 million cubic kilometers of lava and released enormous quantities of carbon dioxide, sulfur dioxide, and halogen gases into the atmosphere, triggering a cascade of environmental catastrophes. Now, a skeptic might propose an alternative explanation for this. And that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine ocean anoxia. The depletion of dissolved oxygen throughout the world's oceans was global at the Permian-Triassic boundary. Evidence comes from pyrite framboids preserved in deep-sea sediments. These microscopic iron sulfide spheres form only in oxygen-depleted water and appear in abundance at the extinction horizon in cores from every ocean basin studied. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, carbon isotope ratios in rocks at the Permian-Triassic boundary show a massive, rapid negative excursion, a sudden global injection of isotopically light carbon into the ocean and atmosphere. Two distinct pulses have been identified, suggesting the carbon release was not a single event, but a stepped process, possibly involving volcanic emissions followed by destabilization of seafloor methane hydrates. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of recovery from the Great Dying took approximately 10 million years, far longer than the recovery from the end Cretaceous extinction that killed the non-avian dinosaurs. Early Triassic ecosystems were dominated by disaster taxa, most notably the Therapsid Lystrosaurus, which constituted 90 to 95% of vertebrate individuals in some early Triassic fossil assemblages, an ecological monoculture without precedent in the fossil record. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: a fungal spike, an anomalous abundance of fungal spores in the fossil record, occurs precisely at the Permian-Triassic boundary in multiple geographic locations. This spike is interpreted as evidence of mass death of both plants and animals simultaneously, providing an enormous substrate for decomposing fungi and serving as an independent line of evidence, confirming the synchrony and severity of the extinction. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Great Dying, Earth's worst mass extinction, and what really caused it. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Siberian traps volcanism triggered a cascade of warming, ocean acidification, and anoxia that drove the extinction. The mainstream consensus, supported by Paul Wignall, Andrew Knoll, and most extinction researchers. Radiometric dating ties the eruption precisely to the extinction horizon. The cascade mechanism, CO2 warming, right arrow ocean stratification, right arrow anoxia, right arrow hydrogen sulfide poisoning of the atmosphere, is supported by geochemical proxies. The main open question is whether volcanism alone was sufficient or required a triggering amplifier. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that methane hydrate destabilization amplified the volcanic warming in a catastrophic runaway pulse. Gregory Riskin's methane eruption hypothesis proposes that anoxic oceans accumulated dissolved methane, which was released explosively, producing a near-instantaneous atmospheric poisoning event superimposed on the slower volcanic warming. The hypothesis is disputed. Most researchers accept methane as an amplifier, but not the primary driver of extinction. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that a bolide impact served as the trigger or co-trigger for the extinction, with volcanism providing the sustained pressure. Impact advocates point to fullerenes and possible shocked quartz reported from Permian-Triassic boundary sections. However, the evidence is far thinner than for the Chicxulub impactor at the KPG boundary, and the impact hypothesis is not accepted as a primary cause by mainstream extinction science. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Great Dying, Earth's worst mass extinction, and what really caused it does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes high-precision radiometric dating, specifically uranium-lead zircon dates from Siberian traps volcanic rocks and from ash layers at the Permian-Triassic boundary worldwide, shows the eruption onset and the extinction horizon are synchronous within the resolution of current dating methods. Approximately 251.9 million years ago, this temporal correlation is the cornerstone of the volcanic causation hypothesis and has strengthened with each refinement in dating precision. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented ultraviolet B damage markers in fossil spores and pollen from Permian-Triassic boundary sections in multiple continents show abnormal morphologies consistent with UVB radiation damage, indicating that the ozone layer was severely depleted during the extinction interval. Halogen gases released by the Siberian traps eruption interacting with coal beds are the proposed mechanism for ozone destruction, adding an atmospheric UV catastrophe to the warming and anoxia. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed fission product migration studies at Oklo and comparison with Permian-Triassic boundary geochemistry aside, the most direct evidence for ocean hydrogen sulfide poisoning comes from biomarker molecules, specifically isornieretane, a pigment produced only by green sulfur bacteria that live in sulfidic water, found in Permian-Triassic boundary sediments. These bacteria bloomed in euxinic, sulfide-rich, shallow oceans, and their preserved pigments confirm that toxic hydrogen sulfide reached the ocean surface. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Great Dying, Earth's worst mass extinction, and what really caused it. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Great Dying is now studied as the closest deep-time analog to current human-driven carbon cycle perturbation. The Siberian traps released an estimated 10,000 gigatons of carbon over roughly 2 million years. Current human emissions run at approximately 40 gigatons per year, a far faster rate of injection into a smaller carbon cycle. Climate modeling of the Permian-Triassic event has confirmed the cascade mechanism, Warming leads to ocean stratification. Stratification drives anoxia. Anoxia enables sulfide production. And sulfide release poisons shallow water and coastal ecosystems. A 2022 study refined the extinction timing to within tens of thousands of years, showing two distinct pulses corresponding to two phases of Siberian Traps eruption. The fungi spike at the boundary now appears in every well-preserved section examined. The 10-million-year recovery time stands as the starkest measure of how completely the Great Dying reset the biosphere. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Great Dying, Earth's worst mass extinction, and what really caused it, from the historical record through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of mass extinction ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.